Hi everyone, welcome to our webinar today. The topic for this webinar is U.S. job creation in offshore wind. This webinar is presented by the Northeast Wind Resource Center, and it is being hosted by Val Stori. Val's a project director here at Clean Energy Group, which is one of the organizations that manages the Northeast Wind Resource Center. I'm going to pass it over to Val in just a moment, and she will be introducing our guest speaker for this webinar, who has a lot of exciting stuff planned for us. But before I pass it over to them, I'd like to go over a few quick housekeeping notes. All of our attendees are in listen-only mode for this webinar, and you have a couple of options to tune into the audio portion of the webinar. You can either call in using a telephone, or you can connect using your computer mic and speakers. If you would like to minimize the webinar console that you see on your screen, you can do so by clicking on the little red, orange arrow that you see here. You can also use that arrow to expand the webinar console if you need to. A very important note, we ask that you please submit questions and comments as you think of them throughout the webinar by typing them into the question box on the webinar console and hitting send. We will be reading through your questions as they come in, and we will get to as many questions as we can as time allows at the end of the webinar. We're planning to save 15-20 minutes for a Q&A with the audience. So we'll get to as many questions as we can. Don't wait until the very end to submit your questions, although of course you can submit them at any time, but type them in soon when you think of them. And a final note, this webinar is being recorded. We will send you an email with a copy of the webinar recording and a link to a PDF of the slides within about 24 to 48 hours. And you can also find copies of all of our previous webinar recordings on our website at cleanegroup.org/webinars. So with that, I'm going to pass it over to our host for this webinar, Val Stori. Val?
Thanks, Sam. Hi, everyone. I'm super pleased to be able to have Alun Roberts from BVGA presenting the results of a jobs impact study on offshore wind in just a few minutes. Before that, I wanted to introduce myself. I'm Val Stori. I'm a project director at the Clean Energy States Alliance, and this webinar is being brought to you by the Northeast Wind Resource Center, which is funded in part by the U.S. Department of Energy's WINDExchange program. It is one of 6 regional resource centers across the U.S., and these regional resource centers are comprised of organizations that are bringing fact-based information and resources from a range of local leaders to the community. Next slide, please. These are the wind resource centers, and if you are located in one of these areas, you can go to the Wind Resource Center's website for more information. Next slide. So today's webinar comes out of a project called the Roadmap for Multi-State Cooperation on Offshore Wind. It's a project that we conceived of out of our work with state agencies through the Northeast Wind Resource Center, though it was at a time when, while there were many expected offshore wind actions coming out of the states, none were yet underway. So the Roadmap project was conceived with New York, Massachusetts, and Rhode Island to see if it would be possible to create a regional market for offshore wind at a scale that reduced costs and that built a local supply chain, a regional supply chain, and also as a way to identify other opportunities for cooperative action in the Northeast. The Roadmap project is supported as well through the DOE, but through their state energy program. It was an award that went directly to NYSERDA, and in cooperation and with the participation of the Massachusetts Clean Energy Center, the Massachusetts Department of Energy Resources, the Rhode Island Office of Energy Resources, and CISA serving as the project coordinator. We came up with this Roadmap project and released the 3 reports you see up on the screen. We also had the participation and received advice from an advisory committee that we set up that included a broad range of stakeholder experts from the energy sector, the environmental sector, and the economic sector. And that committee reviewed and commented on drafts of our work products. Up on your screen, you see the 3 work products we've released. We held a webinar about 2 weeks ago on November 20th on the Regional Market Characterization Report, which was one of the first reports we commissioned that looked at the opportunities and challenges for offshore wind deployment in the Northeast through 2030. And that report study identified a high and a low regional deployment trajectory through 2030. And the report that you'll hear about today, the Jobs Impact Study, based their analysis on the market deployment trajectories coming out of the regional market characterization. The third study that we released was a technical study on the requirements and costs of what it would take to build a U.S. purpose-built Jones Act compliant vessel in the U.S. We also held a webinar on this report. I believe that was back in August. Both those webinar recordings are archived on the CISA website, and you can also find a link up on your screen as a link to all 3 reports. So you can click on that for more information and direct access to the reports and webinars. So with that, I want to introduce Alun Roberts. He's the Associate Director at BVG Associates, and Alun was the lead author on the Jobs Impact Study. We're very pleased to have him here with us. Turning to you, Alun.
Hello, everybody. Thanks, Val, for inviting me to speak. It's a great pleasure. It's a very interesting project for us, and a real great to be involved. So without further ado, I think Val's given an excellent background to the study, so I'll talk you through some of the work we've done and some of the results, and maybe sort of highlight some of the key messages we found there. So first of all, what I'm going to talk about, a little bit of background to the study and the methodology we used, then talk about a quantitative analysis of US offshore wind jobs. That's basically how many there are in different parts of the supply chain. And the third part is talking about occupational analysis, so not so much how many jobs, but also what kind of jobs those are, and finish up with some conclusions and some of the sort of key findings just to finish off with. As Val said, I'm Alun Roberts, Associate Director here at BVG Associates, where I've been for the last 9 years, I think it is now. So I've in a sense been with the sort of early part of the offshore wind industry, and it's been a sort of fascinating few years really, and watching what industry coming from virtually nowhere to being really quite a significant part of certainly European energy policy now. So I thought actually the picture I've chosen there is I thought was sort of showed it off quite well. So in the foreground we have the turbines being installed at Burbank Extension earlier this year, and those are 8 megawatt turbines, and that's the largest deployed wind turbine anywhere in the world, I believe. So one of the sort of monsters being built now. And if you just squint there, if you look on the horizon over to the right of the image there, you can just see some wind turbines on the horizon, and that's the original Burbank wind farm that was built in 2007, using 3.6 megawatt turbines, of which there were about 20-something of those. So that's one of the very early ones, and you can really sort of see the industry sort of coming up to date with the giants that are available to the market now. Maybe forgive me for just a couple of slides on the company. So BVG Associates has been formed about 2006. We're a specialist renewable energy consultancy, mainly working in wind and mainly working in offshore wind, and that's been a strong focus of ours ever since we were set up. And we work in sort of 3 main areas, looking at the economics, and that covers both cost modelling as well as job impacts and gross value added impacts. There's some market analysis, business strategies, that kind of work, and then there's the technology side. And I guess we sort of like to feel that it's the combination of those activities that enables us to provide to our clients, in a sense, a vision for how the industry will develop, and that's, in a sense, that's what, in a way, what we've been trying to do here through this study. And so it's quite a good example of the kind of work we do. So we are clients all over the world now. So as you can probably gather from my accent, we're a UK-based consultancy, and about half our work is in the UK, but actually increasingly overseas throughout Europe, but also increasingly in the US. So it's about 20% of our work over the last year or so. So it's been quite an exciting time for us, you know, in terms of seeing what we can to help the industry grow there. A lot of people know us for the, sorry, I've jumped to there. A lot of people know us for the sort of publications we do. So we've done a lot of work for, for instance, trade bodies, government bodies on the growth of the industry. And so most of them are available on our website, and that's, people I think generally find that's quite a good resource. A lot of the stuff that we've talked about isn't necessarily available in the same way, so I think people find it quite a good library of resources for those who are new to the sector. So, and they're all freely available to those. And so, yes, I'd recommend you take a look if that's if it's useful to you. Okay, I know most of you are probably very familiar with an offshore wind farm, and I just thought I'd pop this slide up just as a kind of refresher for those who are maybe a little more new to it. And this is a skiscape that we produced, and it shows the development stages of the wind farm from going right from left to right here. So on the left we have the kind of development phase with the survey vessels. Survey vessels both in geotechnical, you can see the number 1 there, which is the geotechnical vessel, and we have the increasing use of aeroplanes to survey bird and mammal populations. And then just a little bit lower down you can see a little buoy, and that represents in a sense the wind resource assessment through LiDAR buoys, which is increasing. So we move along to a little way to the left and a little way to the right rather, and you can start to see sort of foundation installation. And so you can see in the foreground, sort of number 6 there is a floating jack-up installation vessel. Sorry, a floating heavy lift crane with installing jackets. And you can see that number 6 at the background. You can see a concrete gravity base being towed into position. So we've put that there, and you can see at the foreground there a cable laying vessel. In the centre of your screen, you've got a turbine installation vessel. Behind that, you've got a shear leg crane, which is often used for installing substations. And as we go over to the right, you'll see the wind turbines operating and the range of vessels that are used there. So we often use this image anyway, just to provide us a context and a framework for our report. So again, if you ever see our reports, you'll see that kind of image recurring, because we find it quite a good starter for people. Okay, just something on offshore wind costs, because in a sense we're looking about where the jobs created. Obviously, that's largely driven by where the costs fall. So this is based also on some cost modelling work we did for NYSERDA earlier in the year. So this is our modelled cost of offshore wind farms in the northeast over the next decade or so. Won't go through all those little sections there, but obviously the top right-hand corner with the orange ones, that's the turbine. Obviously a fair old chunk there, the single biggest order placed by the developer. Going around there in green is what we call the balance of plant, so foundations, array cables connect to the turbines, export cables connecting back to shore, substations. The blue section is the installation commissioning of various components, and then the purple section is the operations. And I think a lot of people sort of, in a way, slightly surprised to see that large section for the operations, because there's just certainly where a lot of people are very focused on building wind farms and getting them built and wondering where the jobs are, but actually it's so important to take that longer term view and just seeing where the spend is over the sort of 25 years or so of the wind farm. It's a large part of expenditure, and obviously a large sorts of jobs over a sustainable period. So quite an important point to bear in mind. Okay, so a little bit about the methodology we use to sort of model the numbers of jobs we've got. What we found is that, you know, we're not a specialist economic consultancy. What we found when we were doing this kind of work, trying to help understand what the economic impacts of offshore wind farms were, is that the conventional methodologies that didn't necessarily work in terms of predicting the number of jobs in the offshore wind supply chain, and that's typically because the economic consultancies usually base their analysis on industry gathered data usually by national statistical agencies. And so in the US, it's the North American Industry Classification System, and there are similar systems used by other statistical agencies around the world. And what you find is that you're struggling to find out how those map onto the supply chain. So one of my favourite ones is you're trying to work out how to model the impacts of blade manufacture. And the nearest code you can find is for glass manufacture. You just think, gosh, yeah, well, yes, okay, so a blade is made of fiberglass, but it's not very different. It's rather different from the rest of the glass industry, you rather suspect. So in a sense, we sort of found that we developed our own method for doing this, and in a way, it's because we were sort of so embedded in the industry and had a good sense of where there was money was spent and how the industry was structured, that we felt we could actually come up with a better method, and that's what we've used here. So the pie chart there is, in a sense, trying to, in a nutshell, is trying to simplify that and show you how we do it. And you think about all the money that's spent. Some of it goes on profit and taxes, some of it goes on depreciation of assets, some goes on the costs of employment, and then the remainder is on payroll. And in a sense, if you're trying to forecast the number of jobs, then it's that payroll bit that's important, and it's our understanding of the industry and trying to isolate that from other expenditure. And then once you've got a reasonable understanding of how much people get paid and their salaries, then of course you've got a way of modelling the number of jobs. Seems quite simple, and it is in theory. Obviously, the difficult bit is actually trying to understand what those values are, and those are just percentages here, just to illustrate the methodology. And obviously those shares vary quite significantly. In some cases, you go across a supply chain. So we're looking right across the supply chain and saying, okay, what does the typical breakdown look like in blade manufacturer or foundation manufacturer or cable installation, and producing similar kind of breakdowns, and that's how we built up the number of jobs. So Val talked about the market characterization study, and so what we did was we took those scenarios, and in that there was an 8 gigawatt scenarios by 2030 and a 4 gigawatt scenario for 2030 for the sort of northeast coast of the US. What we've done to it here is try and give it a kind of fairly smooth profile. The reason we've done this is we don't necessarily know exactly where wind farms are going to be built, but also if you're trying to think about what investments are like to flow from the market demand, in a sense, it's trying to think about what the run rate is, and it's trying to think about what the capacity is, how many turbines it is, and it's those kinds of numbers which give us an indication of whether we think there are likely to be investments that will enable more local supply of components. And so it's those run rates that we see there that are quite important in trying to sort of frame some of the conclusions, and I'll come on to that as we go on. Okay, so here's the results. So essentially with a, pardon me, I've got a bit of a cold, actually. If I cough a minute, please forgive me. So 8 gigawatt scenario, we're talking about 500,000 jobs over the life cycle of the wind farm, of those wind farms, 8 gigawatts, and half that, as you might expect, for 4 gigawatts. I won't go through those numbers in detail, but again, I just really sort of pick out the number of jobs there and say turbine maintenance and service, wind farm operation as being really kind of key numbers in terms of the jobs. And obviously the turbine itself creates large numbers of jobs, as you can see, but obviously you'll get these slides so you can sort of look at these numbers in more detail at your leisure. Okay, so how does that profile look? And so the graphs here are plotted from 2020 to 2030, and in a way that's a bit unfair because we've just been explaining that the jobs be carried on, be created for another 25 years after that, but obviously that will create a very long x-axis and a rather boring graph, so we sort of focus on that 2030 period. But please bear in mind that obviously the purple bars there, which are our operational jobs, will continue for a long period afterwards, and they shouldn't be disregarded. So you can see in our high market scenario, that's the 8 gigawatt scenario, our jobs peak at about 35,000 in the mid-2020s. And what you can see there, if you look in those sort of blue and the green bars there, and then also the orange bars, you can just see the numbers slightly decreasing from 2024 to 2028. And that's because we're applying learning rates to the costs. As you'd imagine, as suppliers become more experienced and introduce technical innovations, that reduces costs. And if you're reducing costs, most of those costs come from reduced labour. And so you do tend to see this slight reduction over time. Also important to point out that in the last 2 years, 2029 and 2030, is that you're seeing quite a rapid fall off, and that's simply because in the market scenario we've used, we haven't considered any deployment after 2030, and so what you can see is that obviously the activity in the supply chain in 2029, which might be, for example, in the manufacture of say cables, which starts quite early, and certainly in 2030, when you've already some of the activities already occurred. So that 2020, sorry, make this clearer. In 2030, a lot of the activity and the jobs and supply chain have already happened because the turbines have already been built, the foundations have already been built, and so you're only looking in that year because we've offset the job creation the year it's happened, and obviously we haven't got any wind farms being built in 2031. And so therefore we didn't have many jobs there in 2030. But obviously, if we were going to get that kind of scenario, we'd really expect that to carry on and continue. And so obviously in that kind of healthy market and the success we'd expect to be in the market, we'd expect those numbers to carry on increasing. But obviously we're just working really with a market scenario that we started with. Obviously in the low market scenario on the right hand side, obviously the jobs around about half. Just the key point here is that you get a less of a decrease in the jobs from learning, and that's obviously in a smaller market you get slower learning, and so in a sense you get a lower fall away in jobs simply because you haven't got that same level of investment. You don't get the same kind of learning rates, so it's a flatter pattern there. You see we use the term FTE year, so that's a full-time equivalent year, and just to be clear, that's one person employed full-time for a year. So it could be 2 people full-time for 6 months, or 2 people employed half the time for a whole year, and that's really the only way in which you can get meaningful comparisons of job numbers, because obviously most people in most jobs are working across different projects or on different activities, and so the FTE is the best way of actually trying to make a realistic comparison. Okay, so what we started to think about now, that we've seen all the jobs that are created from a wind farm. Now, what's the probability that they'll happen in the US? And so we just started developing a methodology for trying to look at that. Now, the first thing was to take out those baseline jobs. That if you're going to get a wind farm, then clearly it's going to create some jobs locally, because otherwise there's nobody to manage or operate it. So we were quite keen that we should actually identify those jobs, that whatever happened, whatever investments are made, you will get those jobs. We played around with the definition here, but essentially we defined a baseline job as when there were no compelling reason why the work would not be taken in the US. And I'll talk through some of the supply chain categories later, and we'll talk through which are baseline and which ones aren't. Then, of course, there's the opportunity for additional jobs, and there are various ranges of probabilities. So you may find different components in the supply chain will be easier or harder to source in the US, or where they'll continue to be imported for various reasons. And so what we've done is we effectively tagged each part of the supply chain for each of the market scenarios to try to paint a picture of how many sort of probability of jobs in different parts of the supply chain over time and for each of the market scenarios. Okay, so I've got a few slides here where I'm going to sort of walk through the supply chain a bit. I haven't covered everything here, but I tried to pick up some of the main components and things. So on this page we have the turbine components, starting sort of turning the left of the cells, and the boxes on the top there where it says high and low. The high and low refer to the market scenarios, so the high market scenario and low market scenario, and you can see whether those jobs are a high probability or low probability in each of those categories, based on the color coding from the previous slide. So the orange there is a medium probability and a red is a low probability. So starting with the cells, in a sense, the first point is that if you look in that kind of market, we're expecting that the US market might be, say, 10% of the European market, if you like, making a comparison. We're assuming that the European market is fairly self-contained. Imagine Asian turbines Asian market will largely be largely independent, but we're expecting for the most part, certainly for turbines, we're expecting that the most cost-effective, the most reliable, the lowest cost of energy will be those currently active in the European market, such as MHI Vestas and Siemens Gamesa. So it's important to think about whether those jobs come to the US is, well, how does the demand from the US compared with that from Europe and the capacity of those factories? So if the demand for the US is about 10% of the European capacity, you can imagine that can probably fairly largely accommodated within existing European supply, and we'll see that across a range of components, because we're expecting in the 2020s the European market will really be quite buoyant. So although the US is picking up rapidly and there's great excitement for all the right reasons, it still represents to be a relatively small industry compared with the one that's been built up in Europe. And again, and the factories will be built in Europe to meet that demand. So in a sense, what we're looking for in these kind of across the supply chain is, at what point does the demand from the US becomes so significant and the transportation costs so significant that it actually starts triggering an investment in the US because either because there isn't the capacity there or because the costs of transportation are high. Now, nacelles are quite difficult because nacelle is a highly complex thing with hundreds and hundreds of individual components. At the moment, those components are all sourced from mostly from Germany. Right? Germany, Denmark, Austria, and Northern Europe, and so to move it in a nacelle factory to the US would require either for all those individual components to be shipped over to the US to be assembled in the US, or for turbine manufacturers to actually find alternative sourcing strategies for each of those components, which is a huge exercise and has significant risks. So what we're saying in a high market scenario, there's a medium probability that will happen. Because a market will be developing, and I think turbine manufacturers will be keen to take advantage of that. But in a lower market, it seems quite unlikely that there is a business case for doing that. So in the nacelles, you can see it's maybe less likely than some other things. But in blades and towers, you can see they're big things. They're hard to move. They can be manufactured independently of other components, and therefore they're one of the sort of first things you can imagine being is one of some of those first investments that you can expect to see. So over and above your baseline jobs, blades and towers are the things that are really hard to move, and there'll be a strong pressure and a strong rationale for doing that locally, provided the market's sufficiently large. Go on to the balance of plant items. Just selection here, so some foundations. I think, well, actually, again, there's not a lot of IP in a foundation. And I imagine they are costly to move, and it's probably one of those things that is relatively easy to find suitable fabricators in the US, possibly most around the Gulf region certainly. And so we're imagining that the cost of transportation will make it likely that really in all scenarios that the developers will be looking to source their foundations in the US. It's not baseline. There's still get a lot of competition from Asian and European facilities, especially those that have invested a lot in serial manufacturing facilities where they will really have highly optimized production processes, which will make the cost quite competitive. But obviously there's a transportation cost, so we still think it'll happen, but it isn't necessarily given, because I think there'll still be competition from Europe and Asia. Got a bit on cables there. So array cables, we talk about what we might call medium voltage cables here, which are in the region of 33 kilovolts to 66 kilovolts usually. What you typically find is that those cables are also made for, certainly submarine cables are also made for things like the oil and gas sector and for maybe short lengths of the island interconnectors or across river mouths, that kind of thing. So there are some suppliers of those kind of cables in the US. Probably not to the lengths and the volumes that would be required from offshore wind. But again, if the market develops there, there's a reasonable chance that we'll see some investment that would enable to meet the demand from offshore wind. Export cables is more difficult. We're talking about cables here up to 220 kilovolts, and these kind of cables are really only used for quite long lengths of interconnectors. And so when you look where the factories are for these cables, they're typically around Northern Europe, often around the Baltic and Scandinavia, where there are lots of islands. There's connections between Scandinavia and the rest of Northern Europe, and those cables factories have actually been built to provide the cables for those interconnector projects, and they've stayed there ever since. So we see them in Norway and Sweden, in Finland even, and it's been hard to move those because there isn't really a demand for other sectors. And so what we found that even with a high demand from offshore wind that we've seen over the last decade in Europe, we've seen in new investments at those factories, but no new factories in export cables. So it's quite a hard commodity to move. The factory lead times are long, and obviously the technical requirement is quite high. So the manufacturers are a little bit cautious about moving to new facilities. and we've seen that despite the fact there's been a shortage of supply. Foundation installation. Val talked a little bit about Jones Act compliant vessels, and in the sense this just does make it quite a complicated area in the sense that we have a situation whereby there aren't really vessels that are really suitable for offshore wind installation currently. A lot of the European vessel fleet, there's probably a fleet of about 20 or more vessels that have been built exclusively for offshore wind. Some of them are suffering because there wasn't quite the market for offshore wind, but there are a lot of vessels, a lot of investment, and so it's quite a tricky situation, and obviously partly why the study was commissioned. So we think ultimately, when the market's big, there is a market for a Jones Act compliant vessel, but it's not. It would really require somebody to have quite a long-term view of the market and the pipeline to make a business case for investment. So I think it's quite likely we'll start to see those investments for in the high market, but in the low market, it's hard to see investments justified for a Jones Act compliant vessel in the low market, where you might be installing maybe only 30 turbines a year. So you can see that actually a vessel for that kind of market is going to struggle, and in those kind of cases, we're going to see what you might call suboptimal solutions with feeder vessels or vessel conversions, which will come with a cost penalty. It is quite a complex area. One area which hopefully less so is in subsea cable installation. Although there's not a huge amount of subsea cable installation going on in the US, there are obviously a lot of telecoms cable installation vessels around, and we suspect also there are plenty of vessels which could be modified fairly easily. So I think with the subsea cable installation, it's much more likely we'll see local vessels being used for that. And let's talk about operation maintenance. I mean, I maybe not need to go into this in detail, but obviously they're baseline jobs in all cases, and that's simply because most of the work needs to be local, and even the work doesn't need to be very local. It's very likely that there's enough experience either from the oil and gas sector in terms of asset management and inspections of subsea equipment. Obviously, there's a sizable onshore turbine industry in the US, so you can imagine there's plenty of experience with companies that do turbine servicing. So there's every reason to believe that those are baseline jobs. And obviously day-to-day operation has to be really fairly local to the wind farm. So if you look at those, so these are the same graphs effectively that I showed you earlier, but then instead of having them divided up by supply chain area, they're now divided by the probability of US jobs. And you can see that in the high market scenario on the left, you can see maybe half the jobs there in that period are baseline, and the rest are either high probability or medium probability. And then you say we've talked through the reasons for that as we've gone through the supply chain. But if you look in the right-hand graph, you can see there are some areas which I'm suggesting a low probability, in that they'll be quite hard to justify the new investments there. As I mentioned, in that kind of market, you've got say 400 to 500 megawatts a year being installed, which probably only one wind farm. And if we're talking about sort of 15 megawatt turbines in the mid-2020s, which is quite possible, then we've really only got 30 turbines a year. So you can imagine that kind of market isn't a straightforward investment decision for many components. So I think in that kind of market, you'll still need to be invested in importing large parts of supply chain, I fear. So I'm going to move on to the second part of the analysis, which is about occupations. And this is really quite a major task in a sense. If you think about all the jobs in the supply chain, we talked about there being 500,000 in an 8 gigawatt market. So it's a big job, and obviously it was our job to try and make that as straightforward as possible. So you start at the top, knowing how many jobs you've got. And then what we try to do is piece together the picture by looking at first the sort of tier 1 suppliers, or the tier 2 suppliers look like, and then maybe some of the bigger tier 3 suppliers. What we sort of established when we're looking through this is that in all tiers of supply chain, you probably what I would call the sort of hidden jobs, in the sense that for all suppliers, you've got the obvious people, the project managers, or the people on the factory floor, or technicians who are actively contributing to the work. But at the same time, they also have lots of back office functions, and you may have a company where maybe 15% of the people in the company are in those managerial, IT, finance, sales and marketing, human resources, all those kind of things. All companies have those, and obviously they are jobs created by the industry. They are supported by the industry, but they're in a sense less tangible than you might expect. But they're all there, and in a sense we sort of treated them separately because we hadn't understood that probably all companies have those people. In sense, at the other end of the spectrum, there are huge numbers of lower tier suppliers. So all companies, for example, are buying utilities, they're buying office services, stationery, they're using transport, catering, all kinds of things which aren't really significant in an individual basis, but they add up to quite a significant amount, and all those services are actually providing jobs. So it's what we did was for those hidden jobs, as we called them, we said, well, we'll consider those all together and say, okay, let's assume a fixed percentage of people who are managers or in human resources or sales and marketing. And then for those smaller tier ones, we're just going to call them other, because essentially that's the whole supply chain. You could come up with thousands and thousands of different professions there. Everybody from couriers through to accountants, and obviously that's a very broad supply chain and almost beyond the scope of what we could try and achieve. So then, the detail analysis was on those ones in the middle, where really there's like what you might call the offshore wind specific stuff, and where we can really dig down and talk to suppliers and find out what kind of jobs there are. So I'm not going to go through a lot of detail, because you can see I've got a lot. If you look through in the report, you'll see I've got lots of pie charts like that, and you'll go crazy after a while. So very quickly, these are the total jobs here on the left, and the baseline jobs. And they don't look terribly different. The important thing is obviously you can see that this is looking at the standard occupational classification at the top there. You've got installation, maintenance, and repair occupations, management occupations, production occupations, engineering occupations, really pretty much as you'd expect in an industrial sector such as offshore wind. Then what we did after this is to go a level deeper in terms of the classification. So these are at a lower level in the standard occupational classification codes that we use. And what I've just got a few charts here, and there's a lot to go through. And I don't want to go through them in detail, but obviously I've picked out a few things just so you can see where the differences are. So you've got blades on the left, and you've got assemblers and fabricators, production operative workers, painting, computer controlled programmers and operators, miscellaneous metal workers and plastic workers, as you'd expect to see in the manufacturer blades. Quite a manual process still. If you're looking at foundations there in the middle, you can see a lot of structural metal fabricators. Obviously, a lot of steel production. In a monopile, for example, maybe 2/3 of the cost is actually in the steel, and so a lot of the jobs will be in those steel working professions. For jacket manufacturers, it's more manual, and you've got more sort of welders and solderers and those kind of professions. So you can see the kind of split there. And obviously in turbine installation, it's an offshore jobs, and you're seeing obviously installation workers. Obviously offshore, we've got a lot of wind turbine service technicians. You could say those are operational jobs, but they're essentially the same people who are involved in the commissioning of the turbines soon after installation. And there's a significant number of those involved in the installation process. And obviously a lot of industrial engineers, health and safety. Obviously you've got the ship crews as well. So that in a sense gives you a sort of cross section of some of the distribution of jobs in three quite different areas. And in the report we go into much more detail for each of the parts of the supply chain. Okay, so that's essentially the results we've had. And just some sort of 5 points I'd like to pick out for you at the end here. Firstly, it will create a significant number of jobs. If you're thinking about 8 gigawatts by 2030, then we're talking about 500,000 jobs, which is really quite significant right across the supply chain. And what we're hopeful for in that kind of situation is that the US should be able to catch a significant part of that. In the smaller market, 4 gigawatts by 2030, then the case for new investments, as we discussed, is significantly weaker. and most of the jobs are what you might call baseline jobs. But I think it's important to consider these are actually still quite significant numbers of people, and it's very easy to get caught up in worrying about what proportion of jobs you've got rather than the absolute number, because you're really just talking about quite substantial numbers in some cases. And significantly, some of those jobs are in coastal areas where I think right across the world we've seen some industrial declines. So some of those jobs are created in quite important areas of the economy. My third point there is that it's a very diverse range of jobs. So this is everything from all the way from accountants down to wind farm technicians. But the key thing is the number that are required at sort of technician level. And these are required right across the sort of manufacturing, installation, and maintenance phases. And that's really, I think, that's the key finding, I think, from the occupational analysis. And of course, as most of you know, there's demand for those kinds of technician-grade skills in a wide range of industrial sectors. In a sense, offshore wind provides yet another reason to support the development of those skills. And I think the key thing here is that offshore wind suppliers will often expect to do most of that investment in their specific training themselves. So one of my favourite sort of anecdotes is that in Hull here in the east coast of the US, east of the UK, Siemens have built a new blade factory. I don't think any of the people involved in that factory have ever made blades before or been involved in the composite sector. So what Siemens wanted was people who are good factory workers, used to that environment and very capable, and they would do the training. So they want people who are good technician, grade people, but there's specific training they would expect to do. So in a sense, for the lesson for those people who try to support skills development is to try and focus on those core skills, because those skills will be used for a variety of industrial sectors. And I think finally, just remember that actually a lot of the jobs that you're creating in offshore wind aren't necessarily visible and in what you might call traditional offshore wind, obvious offshore wind jobs. So they're in there that the industry creates a demand for all those kind of back office functions. And actually these add up to quite a lot over the whole supply chain. So they're not a visible effect, but they still represent a real effect on the economy of offshore wind. So that's me. Probably gone a little bit longer than I expected. I hope that hasn't got too boring for you. Just so you know, I'm sitting here based in England here. I just point out that we have a growing presence in the US, and that's my colleague Andy Geisbuehler, you can see in front of you, and he'd love to hear from you if you're interested in talking more about our work there, or else talk to me direct. But Andy would certainly be delighted to talk to you. So that's what I was going to say. Obviously delighted if you've got any further questions you'd like to ask. Equally, please do take the opportunity to get in touch, or through LinkedIn or by email. I've left my email address there, so please do get in touch, and I'd be delighted to talk to you.
Terrific. Thanks, Alan. Yes, if folks have questions, go ahead and type them in. I've got a few to start with. So, Alan, in the beginning you mentioned how your methodology differs from some of the other methodology that's been used, at least here in the US. Could you review that again for folks? In particular, you mentioned that other methodology relies on industry data, and so how does your methodology differ, and how is it more, how are your estimates therefore more realistic?
So typically sort of conventional analysis we use what's termed input-output analysis based on output tables that are collected from national statistics. So I guess the Department of Labour in the US, in the UK we have an organisation called the Office of National Statistics, which basically collects data on industrial activity across the supply chain, and they assign a number of codes to that. So you have the NIAX codes in the US, and we have a thing called SIC codes in the UK. And so what they're looking at is they're saying that if you spend a pound or a dollar in a particular supply chain, then you can model from those multipliers what the sort of impact is in terms of jobs and gross value added in terms of when you've invested a unit sum in each of those areas of the supply chain. I guess these data are very detailed. But the problem lies in actually saying, well, actually, how do those codes map onto offshore wind? And so the difficulty might be, as you're looking down and saying, okay, I want to understand if I'm spending $1 on an offshore wind blade, what impact will that have on job creation? And you're saying, well, actually, I'm looking through all the codes here. I'm looking at across the tables for different sectors, the statistics I gathered on, and I can't see a category in there. I can't see one of these codes which corresponds to blade manufacture. And so you're left trying to compromise and trying to build up a picture as best you can, but it can be sort of fairly inexact. Another example that I would often use is in, say, tower manufacture, for example, where towers use unusually large areas of thick steel plate. And now this is quite a specific requirement for steel manufacture, and I think in Europe maybe only 2, maybe 3 suppliers who make steel plate of that kind of size and thickness. But if you were to look in the government statistics, you'd find that actually if you invested in the UK a pound in steel manufacture, you'd find actually that the impacts on the jobs that you predict from that would be quite high, because the UK has a steel industry, not as big as it once was, but it's still sizable. And so it'll tell you that if you've invested a certain amount in steel production, that therefore you will get a number of jobs in steel from tower manufacture. You will get UK steel jobs, but you don't get any because all that steel is imported. And so in a sense, it's that difference between actually trying to dig down and understand what's really going on in the supply chain rather than what the statistics tell you. So what we try to do is saying, well, what the statistics are trying to do is they are there because you can't possibly necessarily know all the details of the supply chain if you're not a specialist. But we used to say, well, we are specialists, we know the supply chain pretty well, so rather than rely on government statistics, we'll effectively dig deeper and actually try and isolate, say, the payroll in offshore wind, because we've got a pretty good idea of what the structure and supply chain is and how much people are paid and what the costs are. And so it's that picture that we feel we can build up by a knowledge of the industry rather than relying on statistics which are gathered, which are quite general. I hope that helps. And if anybody wants to, I'm happy to follow up in more detail if that's if it's useful for anybody.
Great, thank you. I think that explanation really helped as well. So a couple of follow-up questions to that then on jobs. Can you explain the difference between job years and jobs? And in the report, where are we talking about jobs versus job years? Where do we need to pay attention?
We've used the term a job year, and that's because it's, as I say, I think we've used the term job because I think some people aren't necessarily comfortable with this. They use the term sort of full-time equivalent, and a job year is simply one job for 1 year, effectively. I guess the difficulty when anybody's talking about job creation, and you'll see it in large numbers of industries and government departments would do the same. They'll say such and such a thing will create X number of jobs, and you think, well, what do you mean by that? Because it could be a job that lasts for 6 weeks or 10 years, and you sense, well, that's clearly something very, very different. So we use the term a sort of job year or an FTE year to say, well, actually, when we're talking about that, we're being quite clear. We mean that the equivalent of one job for 1 year, rather than just talking about jobs which can be interpreted in a number of ways.
Thank you. All right, let's focus on these jobs. Towards the end and elsewhere in your presentation, you mentioned that 500,000 jobs are possible in an 8 gigawatt scenario. What portion could the U.S. capture under the high market scenario?
I think we're suggesting that maybe sort of half of those are what we might call baseline jobs. I mean, what we've tried to do in the study, it's a bit of a simplification, because obviously that even in a base, you might call a baseline job is in operations and maintenance, but obviously there'll still be a role for specialist services and components to come in and be used and be imported, and that's likely to happen. So, but I still think that actually that the US should expect to get at least half of those, I would think. It's obviously a huge economy in its own right, and it should be able to support all those jobs, and those skills are available. The more difficult things are where there are some quite specialist skills, but also where the components are from optimized serial production facilities. And I guess the turbine nacelle is really the standout one there. Is that obviously you're talking about as far as possible highly optimized supply chain and assembly process, and it's not something that can easily be transported. And I guess it's one of those things, if you try to move that production to the US, then obviously then there'll be a learning curve for that factory, whereas obviously you've got very well established labour forces already working on that. And I guess the difficulty around vessels and the Jones Act is the other sort of key area, which is really going to be quite difficult, I think. But I think over time it'll obviously increase as the industry grows and it becomes more established. Then obviously people will see that if it's seen to be sustainable in the long term, and I think going beyond 2030, then you'd expect to be getting up towards 60 or 70%. I would think of the jobs created, but it's it may not happen straight away, and I guess it's probably important for everybody to see the longer term game if the industry is going to be sustainable.
Thank you. All right, let me ask you a two-part question. So if states in the U.S. are going to invest in workforce development training, what sectors and/or skills should they be investing in? And then similarly related, do you have any recommendations on what states can do to maximize the degree of U.S. local workforce engagement in these early projects?
Okay, so the first one, firstly, I won't pretend to be an expert on skills development, but I mean, I think the key things are areas about electrical engineering, technician level skills are often the things which are a particular problem across the supply chain. I think most sectors suffer from that, and obviously the turbine electrical system is particularly important, and I think that's one area where I think is an important area of focus. I think some of the perhaps the other thing might be interesting is in sort of composites repair. Those kind of skills where you can imagine there being a sort of a fairly consistent demand, and maybe it isn't necessarily met by existing supply chain. So yeah, I'm trying to be an expert on skills development, but it's in those technician level jobs where I think where the particular demand is going to come from. And the second, sorry, just remind me, Val, the second part of the question. Sorry, Val, I've forgotten the second part of your question.
Oh, sorry, I was on mute there. Yes, again, if you have any recommendations on what states can do to maximize the U.S. local workforce participation in these early round of projects.
That's a good question, and I think the first thing is to be quite pragmatic. And I've seen projects where they've complained that they only managed to get sort of 10% local content in their wind farm, and you think, well, actually that's actually pretty good. I think the first thing to do is to really pick out those areas where there is likely to be the demand for people working locally, and to try and isolate those, and then make sure that those people are available. And I'm aware one of the sort of obvious winners, I think, that we identified is some things like the onshore grid connection, for example. Onshore substations, those are things that will come locally, and you want to make sure that there are local companies there that are sufficiently aware of what's going on and how and when it's happening, and who's going to be contracting. So again, it's not very exciting, but those kind of jobs are important. There'll be jobs around the construction of the operation space, and there'll be certainly those other services which are supporting the providing what you might call lower tier support to the installation activity. So everything from catering to waste management, communications, those kind of things are the things that people will be looking to secure local services. They, as I say, they're not necessarily terribly exciting, but those are the kind of things that contractors will be looking for locally. One area that we have seen develop locally where there has been sort of early stages of the wind farm is in vessel manufacture. for those not far from Burbo Bank, and a lot of wind farms built in that part of the UK, just off the coast of Liverpool, for you Beatles fans. And there were several boat manufacturers, crew vessel manufacturers, that started responding to that demand quite early. There's a number of businesses that got going there, supplying crew and vessels to the wind farms, and that's been quite an interesting story.
Thanks, Alan. At some point in your presentation, you mentioned that the U.S. has tower manufacturing capability, but not in the right locations. What would the right location be? Where would it make sense?
Right location is by the sea, by the coast. I guess you're talking about an offshore tower. Certainly for the V164, I showed the picture. I think the base of the tower, lower tower section, is 7 meters. So although that your export from the factory is probably done horizontally in 3 sections, and then there at the installation port they'll be assembled into a single vertical section for installation. A 7 meter tower width is probably beyond most road transport, and so this is the difficulty, is moving that kind of that kind of component is too difficult to move on the road. I mean, if it's possible, then great, but generally speaking, you're looking at coastal facilities. And it is a difficult area, because tower manufacturers is a fairly specialist area. If you've got an uncertain market and they have notoriously low profit margins, it's a quite delicate, high-risk industry to be in. And I guess the ideal thing is, if you're someone who has coastal access and good road access, who can actually set up a facility to supply the onshore and offshore industries at the same time, would be the sort of lowest risk solution.
Perfect, thank you. I see that we're running out of time here, so I just wanted to ask a quick clarifying question. What was the geographic range of the study? We've been talking about it in general U.S. terms, but does that include the West Coast and the Great Lakes states?
It does, and I guess I think to keep it simple. I mean, obviously we're talking an industry which is largely on the northeast coast. I mean, I think once you start building that into smaller areas, then obviously it requires a much more detailed analysis of the industrial capabilities in different regions, and that in a way that's a little bit beyond us. So in a sense, yes, we are assuming it could be anywhere. I think in practice you'll know where the industrial areas are. We know, when your sort of fabrication, the sort of offshore fabrication centres are further south, and there'll be areas where more likely to see electrical supply from. But we didn't look into it in much more detail, because it's just I guess it becomes a much more complex equation. So yes, I'm afraid it is the whole of the US.
Great. Thanks. We are closing in on the hour. Apologies if we did not get to your question, although it sounds like you should feel free to reach out to Alan if you have any further questions, and of course you can reach out to me as well. My email is up on the screen, and as Sam mentioned at the start of the call, this webinar is being recorded, and you can access the slides and the recording at the Northeast Wind Resource Center's website. Thanks so much for joining us, and have a great day. Thanks, Alan.
Thank you.